So what's this tool? This is just, it's a scripting language tool thingy. It's something that you write a small program about the pieces of your application. So, like I said, we're gonna piece up the application, whatever you have. You usually get MATLAB code and we don't like it, but we're stuck with it. So we get this one, we get MATLAB PC, well, we get the whole code. Victor makes the pieces that make sense in a logical way. And then in this Swift tool language application, we define the dependencies between the pieces. So for instance, we know this piece has to come first, and then there's another one and another one. And essentially, we express the dependencies by defining these inputs. Like first piece jumps out this file as an output, and it needs to go to the other file as an input. So that's what we do. That's what we tell to the language, and then also tell it, well, look, you can run this piece on some machine. I don't know, on some hardware supercomputer or in the department cluster somewhere. And then this tool takes care of running the whole application on its own. So just say, run this script which defines the dependencies, it's going to run it for you. And does that automatically, and it's extremely useful if you have many pieces that you need to run, or if you have huge loops, and I'm going to show you examples.
Timmy, can I just...
Yes.
So, for example, you guys work with Professor Townsend and another researcher who've created a model that predicts financial deepening, or participation in the financial markets. And they've already written this code, and they've run the model, and so it works. They wrote a paper, but why do they need you?
Well, it works in the case that they used it for. So it also at the stage where the model they came up with. So for the structural estimation part of the model, I mean, it's sometimes it takes huge amount of time to do structural estimation, so they need a lot of computing power to do it. So they come to us for that.
So you're able to reorganize the model and run it with different tools that allows, instead of it taking, days for them to run and predict a model, to run it in much less time?
Essentially, that's what I'm getting at, yes. So, essentially, you're getting a speed up of the execution of the model after we work a lot on it. So this is just the first example. Okay, so this is like a good point to ask you, because the first example is some work that I did with Madeira. This is a guy which you see on the wall. He just graduated 2 years ago, I think. So Madeira worked with Townsend on this mechanism design problem that was analyzing how to organize agents in groups or individually and maximize the profit from exploiting them, something like that. So essentially, the method that they used was to use grids. They gridded up the space, the domain for expressing the relevant variables that they were interested in. So they gridded up the relevant variables, and then they ended up with having a large set of optimization problems. And they were independent of each other because they all had to work on one input from the grid, but there were lots of them. So what we did, I mean, we, like I mentioned, provided the resources and then obtained some speed up in their setting. And what's the conclusion? I mean, while we did this work, you should expect that there's a slowdown because of doing all this decomposing of the application, but essentially there's a gain just because we are having access to, you're sending your code to so many more resources. So just this is an example, really. This is his application. So he had 5 stages that essentially was setting up the problem, and these were expressing the group case for his agents, and this expressed the individual competitive case for his agents, and then he had all these problems, all these parallel optimization problems in them. So I expressed the workflow for all these and then just said run, and it ran. And it spit out the results later, and essentially the speed up that I got was 5 times over what he had done previously. Now, one important problem that I hit, an important point that we see in this kind of work, he came to me with MATLAB and Cplex. Well, we don't really like MATLAB too much for some reasons that I'm going to get to next, but Cplex is a license software, it costs a lot of money, and when we do this, see, all these orange blocks run remotely on some other machine. Those other machines most likely are at some other universities. There's this huge computational pool which is called TerraGrid. It's an academic grid. You can send your jobs to any of those machines really easily. But those machines do not have Bison software. That's why we don't like MATLAB, that's why we don't like Cplex. So in the process of working on this, I had to replace Cplex with an open source solver, and I replaced MATLAB with Octave, and surprise, I got the same result. Actually, I was really surprised, but I did get the same results. So,
what is Octave?
Octave is an open source replacement for MATLAB. It actually runs MATLAB code. So M files that you write, it runs them, unless you use some specific functions from the optimization tool, from some toolkits which are not yet implemented. It's much slower, it's free. So depending on what you do, you can use that. I had to use it because there wasn't MATLAB license available on the other machines in that field. So essentially this is what I did, make his software run on those resources and get some speed up, just because of the parallelism. I had 52 parallel instances of the problem here, so I mean, that's just this block is 52 times speed up, but because overall there were dependencies, and also because of some availability of the resources which I sent this, they would slow down to 5 times speed up. So the next example is like shocks and house, well, if you watch the TV show. So we have this model to which Townsend applies shocks. And this work was majorly done by Victor, the very scripts here, because everybody knows of this. So we got this model from Townsend, and it was something to do with simulating shocks to the entire economy and seeing whatever I said here, tracing the growth of wealth in the economy. So they had 17 years worth of data. They did a structural estimation, I think. They did. I'm going to show you the flow of the application. So for 17 years of worth of data, they generated these shocks to 1,600 households. So they have these two kinds of shocks, and then they traced what happened to the household.